of polynomials. If we divide a polynomial by a monomial, like for example 2x cubed minus 3x plus 1 divided by 2x, the only chance we have is to split the fraction. 2x cubed over 2x minus 3x over 2x plus 1 over 2x. That's our only hope. We separate it into 3 fractions. And we simplify each and every one by itself. So in the first one becomes x squared, the next one is 3/2, and the last one I cannot do anything to it. But this is a specific, very specific type of division. A polynomial by one term, divided by one term. Say it again. Yes, one term. Monomial, one term. Now, if we have a polynomial divided by a binomial, we have two options. But only if the binomial is degree 1. Linear binomial. Not if it's x squared minus 5x. So a polynomial divided by a binomial with degree 1, we have the long division, and we have the synthetic division. We have the long division and the synthetic division. Let's practice. I will hopefully refresh your memory on this. On page 392. Let's start with, let's say 22. 22 on 392. So we have at the top 5x cubed minus 6x squared plus 3x plus 11. And in the denominator, we have x minus 2. Can we use either long division or synthetic division here?
Yeah.
Yes, because the denominator is a binomial, 2 terms, and the degree is indeed 1. So let's do this with both. Now, before I refresh your memory on both a long division and synthetic division, I just want to make a point. If I divide 10 by 5, I get 2 plus 0 divided by 5, which doesn't need to be written. It's 0. But if I divide 10 divided by 3, I will have 3 plus 1/3. And you can say this is not the way we write it with numbers, and I will have to agree. It's a mixed number as 3 plus 1/3. This is for numbers. But for polynomials, I have to write it like this. I have to write the quotient plus or minus the remainder over the divisor. With numbers, this works, but not with polynomials. So the answer will be a quotient plus a remainder over the divisor, or minus. It could be minus. So Q, quotient, R, remainder, D, divisor. Keeping that in mind, so let's start the algorithm. You would like, again, the synthetic division first or the long division? Perfect. Two things we have to worry about. That the polynomials are in descending order, are they?
Yes.
Perfect. Now let's look at the top. Is there a missing term? What is the degree of this polynomial?
There's no missing term.
There is no missing term because the degree is 3. Degree 3 is there, degree 2 is there, degree 1 is there, and degree 0 is there. If, for example, this were not there, I would have had to put a 0 for x squared. But it's there. So everything is there, nothing is missing. So, yes?
Is D supposed to be divided and not division?
No, divisor.
Divisor.
Divisor, sorry about that.
No, it just, I could tell that was an error.
No excuse. I'm standing and I'm trying, but my handwriting is not perfect, even if I don't stand. So my apologies to all of you. Okay, very good. So the synthetic division synthetic division requires us to put in the box. No, that's long division. You said synthetic. We wanted to start with synthetic, right?
Yeah.
Okay, that's fine. So in the box, so the denominator is compared to x minus a. Like we did with the circle, like we did with the vertex of the quadratic function. So I'm comparing and I see that a must be 2. So this is what I put in the box. What if I divide by x plus 5? What will I be putting in the box?
-5.
-5. That's the point I'm making. It has to be the divisor, has to be like x minus a number. That's how I identify a. If it's x plus 5, I will write x minus -5, and this becomes a. Good. Next, I will copy just the coefficients in the correct order, and if one is missing, I put 0. 5, -6, 3, and 11. Next step, I bring down through a 5. The first coefficient gets copied, always. Next step, I multiply 2 by 5 and I get 10, and I write the answer under -6 but above the line. I perform the operations I see and I get 4. I continue with 2 times 4 and I get 8. I perform the operations I see and I get 11. I continue 2 times 11 is 22, and I box in, and this will be the remainder. So now can anyone give us the answer to the division 5x cubed minus 6x squared plus 3x plus 11 over x minus 2? And before you give the answer, I want to point out one more thing. When I divide degree 3 by degree 1, what degree do I get? Perfect. So that's the coefficient of x squared. That's the coefficient of, what is the next in line?
Oh, 5x squared plus 4x
Plus 11.
plus 11.
Indeed.
And then it would be plus 32
5x
over-
squared plus 4x plus 11 plus, do not forget this symbol, 33 over x minus 2. Is this clear? Let's do the same thing with the long division now. Ready? The algorithm for the long division is x minus 2, and inside 5x cubed minus 6x squared plus 3x plus 11. Same idea. Keep in mind that if there is a missing term, then I have to leave space, an empty space. Sure.
When you say there's a missing term,
If this term were not there, I would have put a 0 or left it blank. If I use the space, it's fine. If I don't use the space, it's fine too. But if I need it and it's not there, I mess up the answer. Good. X times what is 5x cubed?
5x squared.
Very good. We go back and we distribute to both terms. We multiply. We change the sign.
5x cubed minus 10x, but then you'd have to flip the sign.
Yes. So it's 5x cubed. Change the sign. Negative 10x squared. Change the sign. These two are gone. We bring down next in line, which is 4x squared plus 3x. Next question. X times what is 4x squared? Yes, and at the top we do not lie, meaning I have to write the correct sign. 4x times x, subtract. 4x times negative 2, it's negative 8x, but I have to change. Perform the operations I see and bring down the next in line. X times what is 11x?
11.
Yes, but the sign.
It's a positive.
Yes,
11.
at the top we never lie. It's not that we're lying in the rest, but you know what I mean. I just want to trigger your saying. Yeah. So 11 times x is 11x, but I have to flip the sign or change the sign to the opposite because I subtract. 11 times negative 2 is negative 22, but I have to write positive 22, and I box in the exact same answer as before. Now you can say, yeah, it works okay, but you haven't convinced me that this is correct. How will I convince you that this is correct? Yeah, you can say you showed it in two methods. It must be correct. But if you say, show me, here's what I would do. I will multiply this quantity by this quantity and add this quantity to get this. So in order to check, I multiply 5x squared plus 4x plus 11 by x minus 2 and add 33. If the answer is not this, if it does not equal 5x cubed minus 6x squared plus 3x plus 11, then the answer is incorrect. You can say, yes, you showed us with two different methods, but maybe you made the same mistake in both, and maybe that's not correct. And then I'll say, okay, I completely agree with you. Let's check. This times this plus this. How do I do this here? 3 times 3 plus 1 must equal 10. So if this x minus 2 times this polynomial plus 33 will equal the top, then we're in business. If it doesn't, then it's wrong. So I'm going to do it right now and continue here with the check. Let's check. X times 5x squared, 5x cubed. X times 4x plus 4x squared. X times 11, 11x. Negative 2 times 5x, negative 10x squared. Negative 2 times negative 8x minus 22 plus 33. The 5x squared I got. The negative 6x squared, yes, I did. The positive 3, yes, I did. And 33 minus 22, I got the 11. So there is no doubt now that we did not make any error in any of the two methods. And the answer is indeed the one we looked at.
You keep that up for just a quick.
Of course. Any questions?
I do have-
Say it again.
Yes, I do have a question.
Yes.
In the beginning for the long division,
Yes.
when you got 5x to the second power,
Yes.
how did we get that?
Okay. So the question is x multiplied by what is 5x cubed? And only 5x squared will work. So x times what quantity is 5x cubed? It must be 5x squared. 5x squared times x is 5x cubed. Copy the base and add the exponents. Is that okay? Oops. Is that okay? So for the next one, where I have 4x squared, x times what is 4x squared? Well, 4x. Right? X multiplied by what is 4x squared? Well, 4x. Only 4x times x would be 4x squared. Is that better? Everyone else? Any questions? Is this okay? Can you follow? Please stop me if you have questions. Okay, so one other concept here before we look at rational functions. I still have a few minutes. Yes, 15. Oh, yes.
Do you pick which one to use, or are they two separate? Like, is it one way you can do it this way, or?
So if it's a very good question actually. If the denominator is x plus 5, x minus 2, x minus 3, x plus 15, you can do both. If the denominator is, and maybe we should look at another example, very good question. If the denominator is, for example, like 14, problem 14, thank you for asking that. Like, for example, x to the 4th plus 2x cubed minus 4x squared minus 5x minus 6, everything over x squared plus x minus 2, the synthetic division doesn't work. It's not applicable because the denominator is not a binomial degree 1. It's a trinomial degree 2. That's one thing. Secondly, we may be specifically required to use a particular method. Then we have no choice. And here, I cannot ask you to use a synthetic division. If I do, you'll say, sorry, I can't. And I'm done. And move on to the next problem, right? But let's do the long division on this. Let's apply the long division on this problem. Are they both in descending order? Are they both in descending order? Good. Any missing term from the top? No. Degree 4, 3, 2, 1, 0. Nothing is missing. Good. First question. X squared times what is x to the 4th? And we do not lie about the sign at the top.
X squared.
Do you all agree with x squared? Yes? Everyone? So now we go back this time to 3 different terms. Careful. So x squared times x squared is x to the 4th, but I have to change the sign. X squared times x is x cubed, but I have to change the sign. X squared times negative 2 is negative 2x squared, but I have to change the sign. Remember, you have to write the below like terms for 3 terms this time. Perform the operations you see. So this is x cubed and minus 2x squared, and bring down the next in line. Because we need 3 this time. X squared times what is x cubed?
X.
And the sign? Very good. Now you understand that if you start with x squared, you must go back to x, and then no x. If you start with x squared and then the next one is x cubed, something is terribly wrong. Okay, so x times x squared is x cubed, subtract. X times x is x squared, subtract. And x times negative 2 is negative 2x, subtract. Take a moment and see if you have a question here. Is this okay? Yes?
Yeah.
Perfect. So these 2 are gone. Then negative 3x squared minus 3x and minus 6. Last question. How do I know it's the last question? Because I have an x squared term and I have an x term, and it must be the last one, it must be a free term.
Yeah.
There is no other way. X squared times what is negative 3x squared, and at the top we do not lie.
Negative 4.
Negative 3.
Oh, sorry. I
That's
saw
okay.
4 up there.
That's
I wrote
okay.
it down.
I copied 1 instead of 2 in the previous graph. So negative 3 times x squared is negative 3x squared, but we have to subtract. So positive 3x squared. Negative 3 times x is negative 3x, but we have to subtract. And negative 3 times negative 2 is positive 6, but I have to subtract. Careful.
Negative 12 over the x squared plus x minus 2.
Correct. So then the answer, I can write it here. Can anyone give us the quotient?
X squared plus x minus 2.
And then minus, because the remainder is negative, 12 over x squared plus x minus 2. Don't fall into the trap of changing I just want to say one more thing here. Let's suppose I have x squared minus 1 divided by x plus 1. The numerator is x plus 1 times x minus 1. The denominator is x plus 1. So obviously the answer is x minus 1. What is the remainder?
So,
I factored the numerator and I simplified x plus 1. So I divided this by this and I got x minus 1. And how much is the remainder?
minus 12.
0 divided by x plus 1. This is a different problem.
Oh,
Sorry.
sorry.
Different problem. I just want to say one thing about this. So what does this mean? Do I need to write this? No, of course not. I'm just making a point. So can I say that x squared minus 1 has a factor of x plus 1 since x squared minus 1 over x plus 1 has 0 remainder? Can I say that? So I divided x squared minus 1 by x plus 1, and I got x minus 1 with no remainder. Then can I conclude that x squared minus 1 has a factor of x plus 1? Because when I divided by it, I got 0 remainder?
Yeah.
Can we say that? Here's a simpler question. 9 divided by 3 is 3 plus 0 over 3.
Yep.
Can I say that 3 is a factor of 9?
Yeah.
Because the remainder is 0. The same thing here. Can I say that x plus 1 is a factor of x squared minus 1 because the remainder of the division is 0?
Yeah.
That's what it's called, the factor theorem. If the remainder is 0, the denominator is a factor. Okay, I think we had enough of that. So let's look at least start rational functions. This is section 3.5. So we have 3.5 left and 3.6 inequalities. I will bring next time a previous test and maybe we can start working on that. So 3.5 rational functions. So remember we started with a linear function and we graphed it some time ago. Then we moved on to the quadratic. And then we moved on to something more sophisticated, polynomials. And this is a more sophisticated even function than polynomial functions. This function, in addition to what we discussed, like end behavior, x and y intercepts, max, min, symmetry, everything, this function has two situations that we will never see in polynomials. So let's discuss those before we choose problems.
Does that say 3.5?
3.5.
Is there no 3.3?
We did 3.3. There is no 3.4.
Oh, I know 3.4.
Yeah, 3.3 was division. Yes, and 3.4, it's zeros of polynomials. That is not on the syllabus. No, it's not there. Unless you want to create one for you and for everyone else. I can let you. Okay then. No. If I don't present it in class, you're not responsible. Okay, rational functions. So let's take a look at a graph like this and a graph like this and discuss those two properties that we will never see again in other functions. Okay, in this class. So let's say we have this situation. Let's say x equals 2. It's a vertical line. And here's the function. Exactly. So when does a function have a vertical asymptote? This is called vertical asymptote.
When it gets close to, but doesn't touch that line.
No, when a rational function has a vertical asymptote when it is undefined. So here's an example. F of x equals 1 over x minus 2. Can anyone tell us the domain or give us the domain of this function?
Because it can't be 2, it has to be negative infinity, comma 2 parentheses, and then parentheses 2, comma, positive.
Therefore, x equals 2 is a VA, vertical asymptote. No polynomial function has a vertical asymptote. How come? Because the domain of all polynomial functions is all real numbers. There is no gap. It's never undefined. Okay, so let's take a look at another situation. This is another rational function. Is it defined everywhere? No. It's not defined at x equals 0. So it definitely has a vertical asymptote at 0. But this function, like also this one, but I want to give you a different example, has what it's called the horizontal asymptote. Say it again. This one? It's not defined at 0. So that's a vertical asymptote. Like this one was x equals 2, this one is at x equals 0. Otherwise, the function will cross it. But it doesn't. So let's go back to the vertical asymptote for a moment. The vertical asymptote is a vertical line. And it's mandatory that the function either goes to positive infinity on this side, or not both, or to negative infinity. And on the other side, at least on one of the two. On the other side, in this case, it goes to infinity or negative infinity. So how many options are there? Negative, positive, positive, negative, positive, positive, infinity, and negative, negative, infinity for a vertical asymptote. At least on one side. In our case, in this class, it will be on both sides. Also, what does this mean?
It means there's a break in the range where
It means this, that as x goes to infinity, the function values get closer and closer to what number?
3.
Exactly. If it goes to infinity, like x squared, there's no horizontal asymptote. But if the function values approach a number, that is a horizontal asymptote for the rational function. It gives us the behavior at infinity. So the behavior at infinity for this function is 3, 3. 3, 3, not infinity, negative infinity as we had with polynomials. So that would be also the end behavior. As x approaches infinity, the function values get closer and closer to 3. As x approaches negative infinity, the function values get closer and closer to 3. Y equals 3 is a horizontal asymptote. And the end behavior. So when we get to work on the table, this will be 3 and this will be 3. But we're not there yet. Any questions? This is totally new. We have never seen this before. Polynomials do not have this kind of behavior. They either go to infinity, infinity, negative infinity to positive infinity, but never a number. Not all functions that are rational will have a horizontal asymptote. So we have to talk about that. So the plan for Monday then.